Suppose you have two wheels, one with a 25-inch radius and the other with a 16-inch radius. If we put them together like this so that they are touching, what would be the radius of the biggest wheel you could fit between the two wheels and the ground? What we have is three different circles that are all tangent to each other and a common line. We know the size of the two larger circles, and we want to know the size of the small circle in the middle. To solve this problem, we can start by recognizing that on the horizontal tangent, the distance between the larger two circles, let's call it d, is the sum of the distances between them and the small circle, d1 and d2. The first thing we'll do is find d. And let's generalize this situation for any two circles so that we don't have to repeat this process later on. If we draw a straight line connecting the two centers, it can be expressed as the sum of the two radii, r1 plus r2. If we take r2 and subtract it from r1, we get this little line segment. And the horizontal line is the same as d. What we end up with is a right triangle. Therefore, we can use the Pythagorean theorem to try and find d. One leg of the triangle is r1 minus r2, and the other leg is d. The hypotenuse is r1 plus r2. To square an expression such as this one means to multiply it by itself. And in the case of a binomial, that means we FOIL. Multiply the first terms to get r1 squared, then multiply the outside terms to get minus r1 times r2. The inside produces the same thing. And the last product gives us r2 squared. Combine the two middle terms, and that's how you square a binomial. Do the exact same thing to the other side, and you should get this. On each side, we have an r1 squared and an r2 squared, so we can cancel them out. Now add 2 r1 r2 to both sides. If we take the square root of both sides, we get this. Take the square root of 4 out, and we now have a formula for the distance we were looking for. Since we already know these two radii, we can go ahead and plug them into the formula. 25 times 16 is 400, and the square root of 400 is 20. So d is 40. Now let's find d1. This is the exact same situation. These two circles are tangent to each other and a common line. Therefore, we can use the exact same formula. Plug in the radii and simplify to get 10 times the square root of r. Now d2. Again, same formula. Plug in and simplify, and we get 8 times the square root of r. We know that the sum of d1 and d2 is equal to d. That gives us a nice relationship between these three values that we can plug them into. And now we can solve for r. Combine like terms, divide by 18, then reduce the fraction, and finally, square both sides, and we end up with 400 over 81, which comes out to approximately 4.938. So this is the largest wheel that could fit between the two given wheels and the ground. If you enjoyed this video, please take a second to like and subscribe. Thank you all for watching and have a pleasant day.